Okay, and Steven does not have slides. Are we going to go put up? Are we going to put up his and what's the GitHub thing? STFCB. Okay. Is that all we need? Do we need to get a should we get these blue sheets going? Stop bragging. What's today's date? The 19th. Now I can see it. My slides, should I be mirroring? We have 2 slides. Tim's?
Yeah.
Which are Tim's?
Timothy.
They're wrapped up with the other slides.
So they
put them all together. Oh, this resolution sucks. Oh, I hate this. Okay. Do we have a meeting note taker?
No. Yep. Good. That's really big.
I know, it's like. All right, we're gonna just have to rebuild it then. I think I can do that. Let me. Yeah.
What's the champagne for?
Well,
Oh, okay.
shit.
You go through the deck?
No.
So I mean, no, it's real thing. So I'm not saying real thing, so I'm going to help you for a second percent, right?
Okay.
Yeah, so we're just saying that you are going to help with once. Yeah, so on the PGL, I'm sure you're going to work with that bunch of things. I got my mission for tonight. We're going to see a smaller than they are. So I'm going to 2%. They have all, I don't think people are the slides, but just
I'm good. Do we have a note taker?
No.
All right, this is the TLS Part 2. If you're in the wrong room, I suggest you find a different room. Do we have a note taker and a jabber scribe? Joe, you're going to take notes, okay? We have somebody willing to scribe, jabber scribe? Thanks. All right then. So I think first up, well, let's just go through the basics here. So you all are familiar with Note Well. We've seen it previously in the previous session this week, and I'm sure you've seen it in other sessions. But basically, you know, if there's IPR you know of, you should be disclosing that. I'm on the wrong window here. Let's see if we can do this. There we go. Okay. So we have our blue sheets going around. Remember when you're talking at the mic to please state your name so that the minute takers and scribes can include that in the notes. And as always, please be professional. I know there's a lot of passionate discussion that may occur today, but let's try to keep it all friendly. So for the agenda today, we'll be talking TLS 1.3, DNSSEC chain authentication, which is just finished a working group last fall. Then we'll have DTLS, and then we'll start talking about the kind of main topic that has come up recently. All right, so Ecker?
I do want to say thanks for giving me a break in between TLS and DTLS, even if it's only 15 minutes.
Sorry, I gotta just get this. Can't see which one it is.
There we go.
All right, let me just get it in.
Yeah, I really thought I'd change that to 99. Can you,
I need to just get to that window.
yeah, hope there's the right slides. Uh-huh.
There we go.
Okay. Okay. So we're on draft 21. Hopefully close to the end. Next slide. Right. So I guess the working group last call number 2 ended yesterday. We had a very small number of issues raised. I'm just going to run through what we did and what the issues were. Next slide. So between 19 and 21, we made a small number of changes motivated by people's comments. So as we discussed last time, I shortened the HKDF labels, thus scraping off a few extra hashes that weren't doing us any good and were just irritating. The labels are now slightly goofier looking, but they're shorter. It took quite a bit of effort, it turned out, to get them like everything into one hash block, but we did finally do it. That's in 20. As per also discussion, we made the post-handshake client authentication option, and there's an extension to negotiate that option. So that's just straightforward. It was in the discussion. At TLS Div and other places, Colm McCarthy raised a bunch of issues about zero round trip. So the two issues he raised were first that PSK and zero round trip both didn't have fantastic stored secrecy properties, which is a little annoying. And we came up with kind of a nice trick to improve forward secrecy in those cases. It doesn't help if you're using tickets specifically, but if you're using a session cache, basically what we did is added a nonce to each new session ticket message so that each, the PSK for each new session ticket message is distinct. So that means that you can issue 20 session tickets. I mean, the tickets are labels in some level. And if you're using a session cache as opposed to session tickets, then you can just basically erase them one at a time. And once they're erased, you can't use them to go back to climb back up the stack. So this is a trivial change that we made. We also added this extensive new section on zero round trip and into replay, and I'll be talking a little more about that. But the basic idea was we sort of taken, after we realized that we couldn't like entirely solve the into replay problem for zero round trip, we took this sort of very nihilistic attitude, which is like nothing could be done. And I think Colm pulled us back and said, well, maybe we should do something. So we documented several techniques for minimizing the replay cost, though not limiting entirely. And there's a pile of new stuff in there that went through a bunch of contested discussion. Next slide. Oh, this is not the new slides. That's unfortunate, but I can just do it anyway. Actually, maybe it's not.
What, is it?
Did I send you a second deck? I think I did, but maybe I just didn't PDFize them.
Yeah. When did you send it?
This morning, but maybe I just forgot to like render them.
Let's see. So
We may need a minute for me to send you a new deck, because actually this is not the deck I wanted. Yeah, okay.
How do I know if it's the right deck?
Just scroll down. Is that it? Because it's definitely not the right deck. That's it.
Well, I have a different deck on this.
Okay.
So,
No, that's wrong too. Give me a second.
is it the same as the DTLS deck or no?
It's possible. I just had two TLS decks. I don't know.
I have the DTLS one.
No, definitely not that.
This is a replay attack, really.
So Joe, I just sent you a copy. Check your
Okay.
inbox.
That's not the right copy either, Martin. I made some changes.
Oh, again, okay, sorry.
Because I'm a paranoid person. Yes, got it. Okay. Just you, Joe?
Yeah.
Should be there. Now. Right.
We'll have a PR number at the top. The same slide. But I'll talk about this. I can talk about this anyway. So during the discussion of this entry replay mechanisms, there was sort of a bunch of back and forth about. So I guess just to take a step back, all the mechanisms we have basically are bounded into replay mechanisms. What I mean by that is that they only guarantee replay, non-replay within a zone of consistency. So if you have like a single server, then you can have inter-replay in that server, and if you have a cluster of servers that all share consistent state, you can inter-replay between that cluster. But if you have two clusters that don't share like consistent state, you get sort of one replay per cluster, and that's the best we know how to do. So that's just the way it is, and so we list a bunch of techniques for how to do that, and all these techniques are at a should. Namely, we say you should do something or other like this, but you have options, and could do nothing. It can be conformant still. Do you have it, Joe? Yeah, it looks better. Same slide, right here. So Ben Kadick had pushed on this and sort of said, why isn't this a must? I think he was quoting DKG and saying, are we designing a protocol that's easy to implement or a security protocol? My sense was there was a consensus, but part of that sense came from talking to Victor Vasiliev. And so I talked to him a little bit more, and he posted this PR basically last night, which represented what he thought he could live with, or I think Ben also can live with, which basically requires that you do something to provide a bounded anti-replay within a consistency zone and doesn't require any specific technique. And this is at a must level. I guess I think we can live with this. I don't know if anybody else has any objections. I mean, it's pretty easy to sort of just claim, it's pretty easy if you don't want to be conformant here to just sort of claim that all your consistency zones are one machine or not do zero round trip. So does anybody object to having a requirement like this? And I'm sorry that, that this PR just came in last night, but that's what it is.
Yeah, so Martin Thompson, I haven't had time to read this, but just skimming through right now, he says that every instance has to ensure that it only accepts the same zero RTT once.
Right.
And that basically means an unbounded state problem, as currently phrased.
So I think the implementation that we work with in NSS, I think would guarantee it, I think as zero round trip is what it has to say.
Right, this is the problem. It says
Right.
It could be read to imply that you have to store
Correct.
for all time
Sure.
all of the handshakes and reject the handshake. But
Sure.
I think you're talking here about accepting zero RTT.
Correct. So I think that the claim we would say would be that you must accept zero round trip, any given zero round trip data as zero round trip once, but you can take it as part of a one round trip handshake once as well.
Under certain
Yeah.
bizarre and there was one of the situations where we've got this window and we will accept it in that window.
Even that only has it as zero round trip once,
Right,
though.
and there's no guarantee on that either. So we have to be a bit careful.
Right.
Because but as zero round trip.
Yeah. Yeah. So I guess people have time to look at this, but does anybody object to this in concept? Okay. Next slide. Right. Previous slide. There we go. So if you look at this HKDF expand label, it has this thing which is labeled hash value. And it turns out that we're using it in cases where the thing that went in wasn't a hash. So this kind of seems annoying and semantic, and Martin has a PR to change this. That's easy enough. So we're just changing from hash to context. But it also noticed we have an increasing, at the time of looking at this, I also noticed that there's all these times when we use derived secret, which then basically passes this thing which is supposed to be hashed into HKDF label, even though the thing that's being hashed is basically a fixed 0-length string. So we have all these places in our code where we're like taking SHA-256 of like an empty string and passing that into HKDF label expand. And this isn't like inherently wrong, it's just sort of stupid and irritating. And it's just necessitated by the API I happen to end up with here. So I think it's probably worth, even though it's annoying to change, I think it's probably worth saying, and I can figure out exactly what I'll do, but roughly say that you can pass derived secret a null value, and in that case, it just passes an empty string to the HKDF expand label instead of passing a hash value. Anybody who's implemented this have an opinion on it? I have, and I have that opinion, but perhaps other people feel differently. MT, do you have an opinion?
Yeah, so Martin Thompson, I noticed going through doing the vectors draft again, and I was sort of skimming through the results, and we do this pretty much once every handshake, and I think it's only once every handshake. I really don't care.
It's probably twice if you do. I think there's 2 cases it can happen.
Okay, yeah, once or twice. It was once or twice I couldn't care less.
Okay, I mean the alternative is you could just keep a table of like the values for each hash.
This is honest. Yeah, at this point in time, it probably doesn't matter anymore because most people have implemented it in that specific way. So
okay. Well, I mean,
it's
I guess less change. I guess less change is better than more change. So if people don't think that this should be changed, then okay. I mean, is it inelegance, right? Barnes, you agree with Hannes?
Yeah, I mean, this is Richard Barnes. I think I agree with Martin and Hannes that like I like the current expression better because it's kind of a uniform implementation, and you can optimize it out, as you said, by having a table of hash values if you want.
Okay, I will leave it as is. Next slide. So the last piece of it is previous slide. Last piece of bit of irritating news. We're starting to deploy this in Chrome and Firefox, and Facebook's doing so as well. And we're starting to see increased connection failure rates. It's hard to get clear measurements. I've heard numbers anywhere between 1 and 10% percentage points. The numbers I drew last night from our data showed about 2% on a baseline of about 1.5. So I just got the numbers last night, so I don't want to like be held to them. But the data we were showing, so like baseline error rates with TLS 1.2 of like 1 or 2% as it is, and then like about 3.5 to 4 for when you turn on 1.3. It only happens when the server accepts 1.3. It doesn't happen when the client sends it. So something the problem apparently is that when the handshake is accepted, not the extensions themselves. So the problem appears to be middle boxes of some kind. We know of some middle boxes which are causing the failure specifically, but that doesn't account for all of them. So there's a bunch of possible things we can do. One of them is do nothing and just sort of, gradually use fallback and have the middle boxes fixed. That actually may not be crazy depending on how big these numbers are. There are 2 proposals, one by Kyle Nekritz, which is to make the connection look less like TLS 1.2 by basically frobbing the content type of the first server hello, the server hello message. That Facebook reports does it improves the error rate some. It's here, so you may want to talk about that. And then David Benjamin, I know, has been looking at making the flight look more like 1.2. And I think Kyle suggested this as well, but basically it looked like a resumption handshake, so people don't get freaked out by the data. As I said, the third thing we can do, when we did the 1.1 to 1.2 transition, people just did fallback and then basically gradually fixed the middle boxes. Depending on how big the error rate is, that may be a viable possibility as well. And we've been looking in Firefox about how to sort of tell people their middle boxes are screwed so they can report them. Between us and Chrome and Facebook and Cloudflare and some other people, we're collecting data on this. So I think we'll hopefully in the next couple of months we'll have much better data on whether anything needs to be done at all, and if so, what the changes are. Hopefully the changes will be outside the encryption boundary, so they'll only be just like annoying wire format, pretending to be other things that they're not. So anybody who wants to actually talk about the data here or wants to volunteer to help, that'd be great. Otherwise, expect an update from me and others perhaps real soon. I don't think we should take, by the way, this PR from Kyle right away, though we will be experimenting with it to see if it helps. Okay.
So just when do you think your experiments will complete?
I think it depends on what we see. I think we'll have data on all the approaches people suggested relatively soon. I would say in the next 4 to 8 weeks.
Okay.
It takes a little while to get things into release, but we can definitely try them on nightlies and betas, and that gives us some indication where they work at all. So we'll definitely have data updates quite soon. Definitive data may take a little longer.
Okay.
Okay. This is the only things I had. Any other issues with TLS 1.3? Probably now is a good time to raise them.
Now is the time. So this is the second working group last call. We've been through this document. If you have anything else, please get to the microphone. Otherwise, we're going to be done. I'll repeat it. This is the second working group last call for this document. If you have anything that you would like to bring up, now is the time to get to the microphone.
Thank you.
We're going to go into next, right?
Yep.
So you break.
Okay, Melinda.
Hi, we just completed working group last call on this extension draft. We've received, we were expecting basically 0 comments, and that is not what we got, but the comments for the most part are uncontroversial and pretty straightforward. So, here we've got a list of stuff that basically needs clarifying language, and I think it's pretty straightforward. Things like the placement of the extension. We've got some text that's redundant between descriptions of what to do in TLS 1.2 and 1.3. We need to make it clear that the RRs and an RR set need to be adjacent. RSIG records, there's a need to make stuff plural. We need to beef up text providing reasoning for including a DNS key RR set. We updated test vectors, disambiguate instances of TLS servers and DNS servers. Remove some stuff. This document describes the data structure in sufficient detail that the implementers can, if they desire, write their own code to do this. That's sort of tautological. Clean up text in the raw public key descriptions, additional description of that in the security considerations, and include some text about caching validated RR sets up to the TTL of the records that are sent down. Next slide. This is the stuff that needs a little bit more discussion. This first one is just incredibly annoying because we've been oscillating on it since the first instance of the draft. It's my sense that pretty much everybody has an opinion, but nobody has a strong opinion. So Schumann proposed that we just basically go with a reference to what DNSSEC does and not worry about canonicalization. Does anybody have strong feelings about that?
So again, this document has been through working group last call, so if you have a strong opinion, please get to the microphone now. Otherwise, we're going to go with what's in the draft.
Or what's what was proposed on the manifest? Yeah. Okay, the use of the UDP label for quick probably needs a little further discussion. It doesn't seem difficult, but it does seem to need a little more thought. Disagreement about where the extension should be located, and this is something that we've gone around a bit on in the past again. So again, if you've got strong feelings about this, now's the time. Possibly add some text about TLS client DNS data caching. Again, this is something that would help possibly implementers, but, somebody with opinions. Good.
So this is actually a clarifying question. My reading of the draft was that the UDP label was being used for DTLS and Quick. Is that still what you intend?
That is, I don't know. I think is the right, at this point, we're looking for recommendations of what to do about Quick, because, there is an ambiguity there in using it for both.
So it seems to me that it's entirely possible you might have two different TLSA records, one that was being used for DTLS and one for Quick.
Right.
And so some method of disambiguation seems to me useful. If you want to call it .quick, that seems fine.
Yeah, I was going to ask if it's kosher to underscore Quick.
Yeah, it seems useful to disambiguate them. If you've been consistently using UDP for DTLS, then just using Quick for Quick makes sense to me personally. I apologize, that was Ted Hardy speaking.
Paul, just to make sure that the any exchanges that are sent happen after encryption, right? So that we don't create a new plain text reference for DNS records.
Right.
Okay.
Yeah, absolutely. And whether, what we should tell client implementers about how to handle unexpected, irrelevant, or extraneous records. Other than that, there were not, there wasn't anything that seemed like a showstopper, which is nice. So what I'd like to propose is that we rev the draft and kick it down the road. Is that okay?
So, but when we're with these particular issues that need more discussion, are we going to close on that before revving the draft?
Yeah, absolutely. We'll get the new draft posted and make sure that everybody's good with it. The question is whether or not we need another working group last call, and that obviously is up to you.
Yeah, I mean, we'll see how these resolve. Right now, I'm thinking that we probably don't, but
Okay.
yeah.
Okay, so we're running out of time for more comments, so please take a look at it and let us know if you spot any other issues. Okay, thank you.
I actually realized there was one more thing that got mentioned on the mailing list that I forgot to put on my presentation, which I think is trivial, but I wanted to mention it. So right now, the certificate type, the server certificate type extension goes in, is supposed to go in a certificate message. Like bear in mind, we just added this at the last minute, and it was all kind of half baked. And so the odd part about that is it seems to imply you could have the end entity extension be end entity have a X509 extension associated with it, and some other certificate having a PGP extension associated, which is nuts. So in TLS 1.2, obviously these extensions should apply to the entire handshake. And so what I strongly suggest is we just maintain that property, which is I changed the entry of the table that says that thing goes in the certificate message and put it back in the encryption extensions, which will retain the 1.2 behavior. And then if people want to do some fancier thing where you can have multiple certificates of different types in the chain, they can do that later. But I'm just trying to keep the 1.2 functionality functional rather than trying to improve it. So I mentioned this in the list. Laurie was the only person who seemed to care about this at all, and he seemed okay with it. So I'm going to make that change unless somebody cares. That seems like the least risky change. Okay, thank you. Now details 1.3. Not too many things have changed, and I've been sort of trying to do a burn down of all the things that are left in an effort to get done. I don't want this to take as long as last time. I've got other things to do. So the only real change in draft 1 is this ACK stuff. We talked about this at the last session. Just as a reminder, DTLS historically had this kind of funky implicit ACK structure where receiving the servers, receiving the other side's flight meant that you were, it meant that your flight had been received. So this seemed really clever, when I did it to myself, but I think apparently it wasn't clever. It turns out you kind of a pain to implement. Whoa, no, I need the previous slide. It's kind of a pain to implement. You get no congestion feedback at all. If you have situations where you have something spread across a bunch of packets, like the server certificate, you don't learn anything about that. And so if you lose one packet, you just have to readjust the entire flight, which is really sucky. And also, every time you had like the last message in a flight, it was always goofy because you had to like sit on it. Basically you had to like sit on that message for a while and eventually time down and decided the other side must have received it. Because the other side was like prompting it by sending you stuff. Unfortunately, when we added new session ticket to TLS 1.3, that just had the pattern of a message sent in one direction that was never like responded to. So it's not obvious what you did about that other than just like, I guess, keep sending it over and over again. There was consensus to introduce an explicit ACK at the last meeting. I had to do some invention because we had some discussion, but it wasn't, what we decided to do didn't work as well as I was hoping. So here's what I actually did. It's in the draft. Next slide. So obviously it's a SAC because SAC's what you want. It's kind of ripping off the quick structure a little bit, though less than I thought I was going to. So the structure is that ACKs contain the sequence number of all the records you received from the current handshake flight. And that part is actually pretty important, it turns out. Obviously in order for this to work, the senders need to maintain a map of which handshake fragments go in which records. That's easy to do, but you got to do it. And the senders are supposed to selectively retransmit, namely that once they know a fragment's been received, they shouldn't be retransmitting it. You can, but you just shouldn't. But the ACK does stop, once you get an ACK for the entire flight, you have to stop retransmission, so you don't get ping-pong. I very deliberately made it a separate record type. If you make it a handshake record type, which is what I think Martin had originally proposed, then you have to ACK that, and that just is not going to work at all. So that was going to make you like a really sad person. And it's sent with the current sending key, which always is the epoch, at the current epoch or above.
Yep. So Martin Thompson, the other thing with that being a handshake message is it adds to the transcript, and then that gets weird.
Right, exactly. So we concluded that was a bad.
Yeah.
The other thing I did, we toyed with requiring the ACK all the time and removing the implicit ACK. But experience with implementing Quick has taught us that was a bad idea. Quick has this odd structure now where you have things which advance the state machine and then ACKs, and you can be in a state where like you're sending the message, you're sending like the client initial, which advances the state machine, and you receive a message from the server that tells you like that must have been received because the server could have sent it to you if it hadn't seen the client initial, and like the server doesn't ACK it, and so now you're supposed to keep like retransmitting the client initial, and that's like goofy. And so I didn't want to replicate that structure in DTLS. It may be inherent in Quick because the layering structure, but we don't have to have it here. So the point being that you have basically essentially two ways to have something ACKed. One is you get the next flight, and the other is you get the ACK. Next slide. So what this means is that, of course, the receiver also has an option about how to ACK, and the guidelines look like this. That if you can move the state machine forward, you should move the state machine forward. When you're supposed to ACK is when you're not moving the state machine forward. So if you receive a message like an NST that doesn't have any in-handshake response, obviously we have to ACK that because it doesn't work otherwise. And then there's a sort of fuzzy text about when it looks like messages might have gotten lost. So what does that mean? This is up to guidance. This has been like, of course, bedeviled TCP for eternity. But the general guidance is if you get an out of order record, then you ought to be like ACKing that to indicate that it's out of order. And if you get a partial record and then you don't get the rest of the next, something that would keep advancing the state of the transcript within a reasonable time. And the guidance that I used was a quarter of a round trip, but that was intended to be just suggestive. People do what they want. It's not really a problem if you basically ACK every time you receive a packet. I mean, it'll work. It just clogs up the network. So this was some attempt to sort of balance that. And very explicitly, you don't ACK anything that's not a handshake message because there's no way to talk about that anyway. And it also avoids this problem of ACKs, which also is a huge pain in the ass. Next slide. Sorry, back up. So anyway, this is the draft. It's been there for a week or so. I don't think anybody necessarily has the time to really study it, but does anybody think this general strategy is a bad strategy? Now's the time. I see we have some transport people in the room, so they could complain about it if they wished. This is intended to be a compromise between like something as rich as the Quick ACK and something as poor as the sort of TCP non-SAC. The open questions for me, I think we talked a little about whether we should put timestamps in the way Quick does, and Ian Sweat convinced me that it wasn't adding enough value, because this is a very short transaction. But that, so I didn't do that.
how many people have had a chance to look at this behavior in the draft? Raise your hand. Okay, not too many
I
yet.
know Martin did. So, certainly, I think we're going to need to implement this to have some level of confidence that it's going to work. We're going to do that pretty shortly. So I'm not expecting to have consensus on it, but this is what it's going to be unless people start objecting, so. Okay,
Somebody's coming to the mic.
are they?
Yeah. Okay, now you should have.
Oh, let me go. Hey,
Hey, can you see me?
why don't you just walk across the room, Jonna?
Hey, John. Yeah, well, I'm testing out the remote participation thing. I just warned against making it too complicated in DTLS. I agree completely that adding timestamps here is not going to be a particular use. I like that quarter RTT for reordering, I think is adequate in general. I haven't looked at the structure itself, but I'd be happy to look at it and talk about how to make it as simple as possible.
I'd appreciate that, thank you. One thing I didn't try to do, unlike Quick, is I didn't try to coalesce ACK ranges. That's one of the reasons why I made it one flight at a time, so I didn't have to worry about ACK range coalescence.
Yeah, but you're right. You're right also in observing that this use case is far simpler than the general case that Quick is built for. You're only trying to do this for the handshake, and you have other information that can be coalesced and other information that you can semantically use because the handshake elicits responses and so on and so forth. I do think that this can be fairly simple and doesn't need to be complicated, unnecessarily complicated. So one thought that occurs to me is instead of starting from Quick, you start from scratch and build something that's actually straightforward. But again, I haven't looked at the actual the Y format or the actual messages being sent here. So I'm happy to look at that and talk to you.
That'd be great, thank you. I think you can red button him.
How do I?
Okay. Second technical point is everybody's always been sad about how big the TLS header is, and the DTLS header is even bigger. We're hoping there's like not a bunch of gnats in the middle box of DTLS enforcement. I don't think there are. I've never heard of one. We certainly want to remove the nonce because the nonce is just cruft. And we should be able to remove the content inversion. And Martin Thompson contributed this sort of proposal for a reduced header format. His suggestion was that we combine the epoch and the sequence number into a 2-byte block with basically these first 3 bits are demux bits because we have like other stuff which depends on what the content type is. What's apparently the content type, namely the first byte. And then the epoch and the sequence number are things labeled EE and SNS, and they're just taking mod, whatever the size of the thing is. I think, I don't know if we have an implementation for this, but it seems straightforward and it should work. Obviously, this would only be for the encrypted traffic, not for the unencrypted traffic, and the cutover is very clear. So I think this is a pretty good, I was a little grossed out by the design initially, but I think it's a pretty good design, so I'm planning to merge that in unless people think they're sad about it. This basically reduces the overhead of a DTLS record to 4 bytes plus the integrity check.
Yeah, so more on this one. We currently have, I think, the range between 20 and 64 or something reserved for us in this demux thing. And we use the space only the lower half of the 20s, I think, for this.
Yes.
And this uses the upper half of that range from 32 onwards.
Right.
And I think that's pretty reasonable in terms of we can use that entire space, and it allows us to cleanly distinguish between a handshake message, an alert, and the encrypted messages that we might send. And I don't see us using too much more content types in the clear.
Is what this space is for, right?
Right, yeah. I mean, we're putting the content type inside, and that's a good thing.
I mean, basically the only way, essentially the only point of having something different than this would be if you felt like for some reason you wanted to have much longer outstanding counters, and Martin convinced me that this is enough bits for the sequence number.
Yeah, so I convinced myself, I may convince others. I'm not sure that I've actually convinced Ian Sweat, whose opinion on this I respect. So I'd like a little more time. We can add an extra byte.
Yeah.
It would kind of suck, but because then it's genuinely too much.
Yeah.
I can forward the analysis that I did on this.
That'd be, please do forward it to the list.
So for me, like the thing about this is like if the IoT people think like this is like something we should make bigger or smaller, like speak sooner rather than later, right?
Right. I mean, I think the IoT people would like it smaller. I think this is about the smallest practical thing you could have. I mean, you can see how many bits you have left. If you just, I think everybody would agree that a 3-bit sequence number is too short.
Yeah. So Martin Thompson, there is one optimization we could make in addition to this, and that is to remove the length.
Right. To require. So right. So I think
which would require that you put these. Every single record is
right.
The entire payload of a UDP.
So I think I guess what I would say
that is something we should consider.
Right. So I thought about that. The issue with that is that it actually makes it makes some of the things it makes this acting more problematic because the acting has to be a separate record and now it's to be a separate UDP datagram. So it's a trade-off. One thing you can imagine doing, I think, is having an extension that said, like, when we first looked at compressing DTLS, one of the things we said was imagine having an extension that said, I don't pack multiple things in, basically.
Yeah. And the other way to do that is to have some internal framing.
Yeah.
You have content types on the inside that do the internal framing. So you can say, I've got an ACK and some other stuff in here. We should think about that.
That's another proposal as well, yeah. So maybe we should workshop this a little bit.
Yeah, the real challenge with this is those cases where you're actually changing keys. You can't do the packing thing.
Quite so, yeah. But no, it's an interesting point. This is we already have the internal content types that we could, but then we need internal lengths too.
We would need an internal length for those content types. So I imagine that for something like an ACK, which is usually the thing that you're packing with other things, you would say, this is an ACK frame, and it turns out that the first part of it, like this is an ACK packet, and you have an ACK in there and something else.
Having to read those backwards is pretty gross too. So I think
you'd read from the front once you.
Maybe we could chat with Hannes about this, because I know Hannes cares about size, and maybe we can see if we can come up with something that's clever.
I think we can come up with something clever.
Yeah. So I think, so I guess I'm reading this may not be as good as we can do. We should hold off on purging it in. Okay. Last thing that I want to talk about is these connection IDs. We got an enormous amount of time on this. So the base situation is that IoT and anything that doesn't do a lot of transmission and things behind NATs have problems with NAT rebinding and things like that. And Quick has this functionality we talked about introducing for details a number of times. Just using the 5 tuple causes problems. Unfortunately, connection IDs are also like a clear privacy problem. And while we spend a lot of time thinking out how to do privacy for delivering connection IDs, I've seen none of the proposals I've seen are adequate. I think, especially for people to be willing to adopt in DTLS. And none of them also, by the way, are completely baked, which is a little unfortunate. Speaking as one of the bakers. This is a huge privacy problem, I think, in the browser context. I'm less sure it's a problem in the IoT context where people aren't actually moving around a lot. It's important to distinguish between mobility and NAT rebinding. And for mobility, this is like a lot more important than for NAT rebinding in terms of privacy. So my proposal for DTLS is actually to kind of punt, which is to say to use have a optional but fixed connection ID, namely you negotiate use of connection ID, but the connection ID doesn't change without the connection. And then if we figure out how to do something better later, because you're already going to have to use an extension to negotiate the functionality in particular, we can just have a new extension that negotiates the better functionality if we ever figure that out. I guess to lay my cards on the table, the structure I'm aware of for connection IDs that I think scales the best, requires passing a token back and forth to every packet effectively, and I don't think people are going to take that for DTLS. I don't think they're take it for Quick either, by the way, because we had that conversation in Paris. So that's what I propose to do. Let me just show the slide of what this actually would look like, and then we can debate it, I suppose. So there'd be a very simple connection ID extension that looked like that, and it would just contain the connection ID that you proposed the other person used sending to you. And so the structure would be that the client offers this functionality and sends the connection ID he wants the server to use. The server responds, or not, with the connection ID he wants the client to use. These can be zero length, and zero length means I'm happy to do this, but I'm not gonna. I don't want you to send one to me. And then you and they get packed in the record right after this epoch sequence block. And so if they're zero, they just don't appear at all. So there's no increased length size, no increased framing size. And I think where you would use this, you use this on all encrypted records that weren't early data. With early data, I think you wouldn't use this because it's too hard to figure out what you should use. So I think if we're going to do something like this is a pretty reasonable proposal. I'd be happy to hear objections to this general strategy as well. This is an attempt to solve the problem. Solve the problem I think is most pressing while leaving room for solving the problem that I really wish I could solve.
Tobias Gonn from Huawei. So this connection ID is indeed a very big problem we currently have in the IoT space. And we are not talking, like I observed also Hannes' draft, and there was like a lack of entropy space in the connection ID because like a few 100,000 doesn't necessarily cut it when you talk about IoT. It's like millions, maybe billions.
Yep.
So I hope the byte length is kind of okay for that. Two observations. First, we need this as soon as possible. I'm not sure whether we can fit it in 1.3 or whether we need to extension of 1.2. Second thing is the privacy concern is also absolutely correct. What we see here, or what I see here is you need to be able to renegotiate the ID, obviously. Ideally, the ID is server set, not client set. That would be my suggestions or my 5 cents.
So when you say server set, I mean, do you think it should, I was making it receiver set.
Receiver meaning
that
the device or the server?
That you indicate the client ID to be sent, the connection ID to be sent to you. So the server would set the connection ID that the client sent him, and the client would send the connection ID the server sent him, which I think is what people actually want.
The point is the client should not be the person to define, to select the ID in the space. Yeah, so you need, when the client talks to the server, the identification is done by an ID that the server can manage. Because what you want to avoid is collision in the space.
Right.
And if the server controls the ID, then you avoid that collision.
Right, so this design, I think, gives you that.
Yeah.
Okay.
Okay, so, sorry, just
No,
echoing
please.
and supporting,
Okay.
okay? So please, if you can do that for 1.3, that would be great. And currently on the timeline that I'm seeing, I actually would also hope that we could do this in 1.2.
So, I mean, this extension, of course, would be usable with both versions. I mean, if we chose to make it that way, I don't have a way to update the connection ID here, and that's not something we know how to do for 1.2. So,
So to respond to the device, I believe this proposal does what you're looking for, since there are the data flows in two directions, similar to IPsec. For the receiving side, you have to pick something, otherwise you may have collisions because you talk, while not necessarily true for IoT cases, but you may talk to multiple different servers, so you want to, for the incoming traffic, select something that you can actually demultiplex. So I think it does that. And I leave it to the chairs to decide on whether, how the future of DTLS 1.2 looks like.
Ted Hardy, clarifying question on how this might get used if we were trying to use it with the SCTP over DTLS stuff in RTC Web. Would you anticipate that we would need about the same site connection IDs to get NAT rebinding there? Or given that this is actually browser-based behavior, would you assume that the browsers would be a little bit more concerned about the privacy properties that you described before and would not use it in that context?
So I guess I don't think, I mean, so in taking a step back with the browsers, I actually wouldn't anticipate being able to use WebRTC just because so many WebRTC applications are RTP and there's no mechanism for this in RTP really.
No, I was thinking of data channel.
Yeah, I understand. I'm just trying to think about like whether or not we have a, I'm just trying to think about like whether, I guess true confession, I haven't thought that much about any of the unaware mobility situations in WebRTC, and I'm not sure they work at all. I mean, these designs with unaware NAT rebinding typically assume that one side basically has a completely open, connection, because otherwise you get rebinding, the data just falls on the floor. And so I just haven't thought about enough whether or not it's even viable to have enough WebRTC settings where they'd survive NAT rebinding at all. Certainly any client-to-client settings is very problematic there.
So perhaps we should talk about this offline.
Yeah, let's please.
I think the real question is if in the future this is present and can be used by aware NATs to delay rebinding because they know that the connection ID is there. So let's talk about that.
Yeah, let's talk about that, because I think the question of whether we can do anything that's aware to see is very interesting. I just haven't thought it through.
Hi, this is Nikos Mavrogiannopoulos from Red Hat. I have a question. Why do you have a free space for the connection ID? Why does it have to be 255 bytes? It seems so expensive, excessive. If you allow the client to send such a big connection ID, are there any uses for being so big?
I have no use for a number that big. I just chose basically my general practice when choosing TLS ranges is to max out the range, because if you do something foolish, then you're foolish. But we could if we decided for some reason that there's no reason to connection ID larger than X, just to make that number smaller. I mean, it's not consuming any space on the wire unless you make them that big.
I don't know if there are any IPsec guys here, but in IPsec there is an SPKI, a 4-byte field. I don't know if it ever caused the problem.
I do know there are data center settings where people would like connection IDs longer than 8.10s, because 8.10s is trying to be a little problem for quick.
And I would also like to add to the previous speaker that I would really prefer if the connection ID is not selected by the client, who may not know what the server keeps a state, but by the server. Yeah,
so I guess maybe I should clarify how this is supposed to work. The way this is supposed to work is the server picks the connection ID for packets that come to him, and the client picks the connection ID for packets that come to him. And so, my assumption was that the server doesn't have an investment in the connection IDs he sends. He only has an investment in the connection IDs he receives.
Okay, yeah, that was missing. Thank you.
Hi, Daniel Kahn-Gilmore, ACLU. I wanted to ask two questions related to the privacy concerns. One is that you seem to justify this on the basis that IoT devices are unlikely to be mobile. Do we have evidence for that? My understanding is that IoT is also active in vehicles. I'm surprised to hear that we think that IoT are not going to be mobile. So that's one thing. If somebody has a response to that, I don't know, maybe Hannes will. The second thing is that this looks to me like a field for arbitrary metadata insertion into each packet. And particularly with the long length, basically each peer can require arbitrary metadata insertion. This looks like SPUD, but we're not going to call it SPUD. And I would rather not do that.
Well, let me make my threat of violence clear. Now you have to solve it. Because if you don't solve it, this is what we get.
So
for those who weren't at HTTP yesterday, I'm echoing what DKG said to Martin.
Are you going to jump in now?
So I'm channeling Victor Vasilyev. So why is this an asymmetric connection ID scheme?
Yeah, so the reason it's asymmetric is to address the issue that Nikos and Tobias were raising, namely to allow each side to dictate the packets that they're going to be receiving. So any symmetric scheme, because if you have unstructured IDs, it doesn't matter, but it doesn't mostly matter. But if you have structured IDs, then typically people want to pack the target thing into the connection ID in some way. And so the idea is that if you say, for instance, bake the load balancer, the thing behind the load balancer identifier into the connection ID, then you might not want to have a random value, so that means you need to structure it.
Just Martin Thompson to expand on that point. The whole point of this is to mark packets so that the receiver can get them to the right place. And it has to be asymmetric. There's a mess in Quick in that regard, and I think this is a far better design for something along these lines. I got up to say that I think this is enough of an attractive target that I don't want to see this in DTLS 1.3. I want to see this as a separate document. And that'll address the concerns that people had about TLS 1.2, because we can hit both of them at the same time. We can have these discussions about arbitrary metadata insertion, because I think it requires some meat. And I think we should probably put in the, here's how you signal the ability to change the thing. And that requires some thinking about ACKing for TLS 1.2. Yeah. Or maybe we just don't do it for TLS 1.2, but
the structure of this is such that we can perfectly well add as an extension, so I don't have a problem with adding an extension later.
Yeah. The main thing I'm concerned with is if we just do this, we don't get the the ability to change the value over time, which is important for the mobility case. It also makes the arbitrary metadata insertion thing worse, but we can talk about that.
I mean, so my interest, I mean, just to be clear, my interest is in getting detail 7.3 out. I think this feature people want. I'm trying to like accommodate that, but if breaking up into two specs solves that problem, I'm happy to do that as well.
Christian Wittemer. Yeah, pretty much what Martin says. I mean, we have to do this thing right, not fast. And the quick and dirty stuff is not going to cut. I mean, you absolutely want to be able to renegotiate it or to get several of them. Otherwise, if you don't have the renegotiation mechanism, the privacy hole is so huge, it's a bad idea. And yes, you might try to justify the fast and quick and dirty thing by, hey, the use case is this and that, but it is not. I mean, it's WebRTC, it's not the browser, right? And so you want to have renegotiation. You probably want to make it optional so it's not present in every packet.
That's actually, of course, yeah, that's saying so much harder, right? That has header bloat.
And you want to have some kind of constraint to make sure that you don't get these huge privacy holes there.
Well, so let me actually try to incorporate some of the stuff I'm hearing just and come up with a concrete proposal for what we ought to do. I feel like where a lot of the stuff with Quick got bogged down, and as I think for those of you who aren't in Quick, probably the proposal that probably has the most legs in Quick is just omitting the connection ID in some cases because we couldn't figure out how to really encrypt it. I'm not saying it has legs, but it's the one that has the most as far as I can tell. So I think the question is, should we attempt to build something that is approximately a fixed ID with a way of changing it, or should we be attempting to build one of these unknown structures that has a way of like constantly changing the connection ID? And I think the thing that motivated this proposal was an attempt to get past the technical problem that we didn't seem to know how to solve and solve part of the problem. So I think there's something like Martin suggested, which is basically we have a fixed connection ID that we can change, and that we know how to do. The other things we actually know how to do. So I think the question is, should we be pulling up on down?
Yeah, but I mean, we have to have the change mechanism from the get-go.
Okay.
We should not do this. We should not try to shove it in without having done the complete design.
Sure. I guess I don't think a change mechanism is the problem. The thing that we don't know how to do is constant changes. That's the part we don't know how to do.
No, that I'm fine. I don't want constant change in Quick either.
Sure.
But we can have strategies, okay? And there are strategies that are midway between constant change and change on expressions. And we need to negotiate too, but we need to enable that from the get-go.
Sure. Well, I think I can certainly prepare a separate draft that implements this strategy. I think it may or may not have may or may not have changes for TLS 1.2 because, as Martin points out, that's much more difficult. But I think TLS 1.3 changes are very straightforward.
Okay. Oh, should we? Yes. Okay, Jonah.
Hey, thanks for discussing this here too. I think I largely agree with what Christian just said, but I'll perhaps reiterate. Maybe I think I agree. I think it's useful to have the ability to change the connection ID because in Quick as well, I think we are falling on the side of wanting to at least change the connection ID when the client knows that there's mobility. When there is actually a network change, we want to be able to change it. If you want to keep changing it throughout the connection, that's something that, as you suggested, is possible to do, but it's pushing it further along. But that middle ground is important, and I don't think that we should lose that by having a fixed connection ID throughout the connection.
Ben Schwartz. So in addition to the privacy issues within a connection, it looks to me like if you're a client and you're trying to keep track of a bunch of different servers, the logical implementation of your connection ID in this situation, especially if you're really concerned about length, is as a counter, basically. And so I think the result is that you may encourage clients to create a cross-connection linkability, where I can see a bunch of connections coming out of a net, and because they're all in some sequential range, I can say, well, these different connections might actually all be the same client. So it would be nice to find a solution that doesn't encourage that.
As far as I know, it requires making them twice as long, just because of the birthday paradox. Well, I guess maybe, yeah. Guidance wanted.
This is Hannes. I would like to talk about the privacy aspect and the previously raised vehicle thing. We wouldn't have a problem in the IoT case for the use cases we care about if the NATs, or if either the NATs wouldn't exist and wouldn't do a rebinding, or if the devices would just continuously or more frequently send the traffic. And unfortunately, they do. So in terms of privacy there, for those devices, there's the connection ID is nothing else than the source port. It's the same issue. Where things get more complicated, and I think there we had, and I disagree with Christian's assessment of quick and dirty, we had a long debate on different solutions for some of the quick use cases where you have, you switch from one connection to the other, have some mobility cases and so on. But they are less of an issue, at least today in the IoT world, because, for example, the mentioned vehicle, most likely this vehicle is not going to attach to wireless LAN as it drives around. It's actually going to use probably cellular, keeping the same sort of context open and then communicating something there. And on top of that, there's always the option to restart from scratch. So for example, if you lose your IP address because you get it reassigned or because you attached a new access network, then you'd have to go through this step anyway. The connection ID will not make a big difference. You just use the full exchange, the full DTLS exchange. And because it's more optimized, it will actually be faster anyway compared to what we had in DTLS. So some of the proposals that we entertained, they weren't much different from actually running the whole exchange in terms of like sending a big ticket in every packet is not going to be very helpful. That's why we don't have it. That's why we have a simple approach. And if you want to, if you, for example, switch the connection, you can actually do a resumption PSK exchange, which would be very efficient. So because that's what in DTLS 1.3, that's what an alternative design has to compare against. In DTLS 1.2, it's a little bit different because you have more round trips, you have the latency and so on and so on.
Tobias Gondor, Huawei. So for these connections, so first, yes, mobile devices are, at least in the use cases that I see. Having said that, when you consider the renegotiation, consider that the main use case that at least I see currently is devices with power constraints. So that means every round trip, every kind of CPU processing time is really, really costly. So smaller bits that are just long enough to qualify is good. Not renegotiating every time obviously would be suicide kind of in that scenario. So things that are like, which you can tailor, which you can customize. Let's say you can choose when you want to renegotiate or not. Yeah, don't push it on it. And one last thing, so I rather have to really soonish. Yeah, because the problem is out there. Yeah? It's not like we're sitting on something in our ivory tower. And yeah, if you want to think longer about this for 1.3, then I would strongly urge the chairs to consider 1.2 so we can get to some solution. And I mean, Hannes draft is going in an interesting or good direction for that. Thank you.
So I think, oh, I'm sorry.
Okay, Jana.
I want to respond quickly to what Hannes said. I agree that generally sending something in every packet seems like quite a bit of information and quite a bit of work to do in complexity. But it's doing it on a mobility is not that onerous a burden. It's only a set of connection IDs that you would have to send. And it's not. I don't think it's true that the mobility case isn't expected to be the normal case. We don't know. This is getting into predicting the future and how exactly DTLS 1.3 will get used. And I would shy away from that. In that there are likely to be situations where you do have mobility, especially going between Wi-Fi and cellular networks. And those are conditions that you want to prepare for. So if it's not too onerous, and if it can protect us from something that might happen in the future, it seems completely worth it.
Okay,
Oh,
so
I did have one more question. I'm sorry. That's why I actually came to the mic. I didn't quite catch your response about why do you have 255 bytes here again?
Can you say that again, Jana?
Why do you have 255 bytes?
Purely because the way the TLS framing works, that any field that when you have a variable length field, then you have to put a ceiling on the value to tell you how long the length base has to be, and so the first ceiling up is 255. We could make this number as small as we wanted. This is a variable length structure; it's not a fixed length structure.
Understood. I'm just wondering if it'll help DKG's concern about having this giant space, which basically becomes, but like by saying that this is 8 bytes or 10 bytes and the rest of it is padding or something like that. If you need.
Yeah, I mean, I strongly suspect any number large enough to be useful is going to be too big for DKG, but I mean, no problem. If you want to make this like number 16, I got no problem with that.
Yeah, Martin Thompson, I agree with that last point there. At the point that it becomes useful, it also becomes useful.
So I guess, in terms of action items, what I'm hearing is that I should go back in collaboration with Hannes and perhaps some other people, try to produce a draft, which is a self-contained draft, has an extension for this, and also has some mechanism for reconnection IDing, and bring that back, and then we can discuss it. I think that's the last slide. These are, I guess, slightly unlike before. I guess these are the only actually remaining open issues I know about for DTLS. Obviously, if to resolve this header issue, and we just taken the connection ID issue off the table. So, I would very much like to come up with a header proposal in the next month or two and send it to the list and then be done. And so if other people have things, I know people expressed in private or perhaps in Hacker News that they were sad about things in DTLS. I'd really like to hear about those things now if we're going to make changes, so I don't hear about them in 6 months. So if there are things that make you sad about DTLS, please do tell me so we can fix them.
So to echo that point, for all the people that are sending me email about when DTLS is going to drop compared to TLS version, now's your chance. If you think there's something that's missing, get to the microphone, send an email, do it, because there's not a lot of issues left that I think we're actually talking about.
Okay, I know people are very excited about the next topic, so I'm going to sit down.
So we're going to do a little interrupt here from the chair's prerogative perspective. So Steve, thanks for getting that. The first thing is the next set is the rules of the road. We've talked with everybody that's presenting. Pretty much we've told people to keep it short, kind of to the point, not to kind of repeat themselves. We have lots of time for discussion for this particular topic. So let's hold the particular points about this, that, or the other till after Stephen is done presenting. So Steve's going to present, and then Stephen is going to present. So we'd like you to hold that. We want to kind of address both political topics and technical topics in this discussion. So we know this might not be a clean split, and we would like you to think about that. We want you to help us get to a point where we can actually do the chair questions, which is the next slide, right? Which is the main question: is this the subject something that the working group should consider? And this being passive decryption of data center traffic, and why you might do that is a sub question. I think is this wiretap or not? I know that I've talked to the people that are about to present. They have a thought on that, and let them do that. Let them have their slide, and then after that we'll have some technical discussion about what technical solutions are available, et cetera, et cetera, et cetera. So, and the point is that if we did ever get to the point where we're going to adopt something, everyone has to understand that the working group has changed control of the document. So what you're proposing now, Steve, and the other people, we can take it drop it, rip it out, start over, kick the authors off, put new people on if we wanted to, the whole nine yards. So like the working group actually has change control. One of the things we want to do is also, if anyone that's presenting on this particular topic would like a mimosa, we're willing to provide one. So from there, Steve, thanks. Yeah, so we have a kind of, Steve has, there's a bunch of like kind of flow for this. So we're gonna go do Steve, Matt, Tim, Russ, and then Steven's gonna get up and do his stuff. And we have like multiple, there's like 5 people presenting on this entire topic. So, and again, like we're gonna have like an hour after Stephen Farrell is up. So plenty of time for discussion. So again, hold your, you know, discussion points till then, and then go from there, because we'll be able to be well within time. Thank you.
Yeah.
Hi, I'm Steve Fenter. I want to try to talk about why static Diffie-Hellman is important for enterprises and for TLS, not just for enterprises. I also want to try to respond to some of the comments and questions on the list in terms of other solutions that people have proposed and why I think they don't work and why we need something like static Diffie-Hellman in order to get our work done. These are some of the major use cases for out-of-band decryption in data centers today. A lot of them are security related. I think there are good reasons for them, but I'm not a security guy, so I'm not going to wade into the security discussions. I'm a troubleshooter and a network guy. So I'm going to focus on the first one, the impact of TLS 1.3 on troubleshooting, particularly Wireshark PCAP type troubleshooting. So this is the application I introduced in Seoul for those that heard my presentation there. It's an eye chart on purpose to show the complexity of an internet-facing application. And just basically, you know, you come in the internet on the upper left, you hit the main processing path in the middle of web server, app server, middleware. The mainframe's at the bottom. There's load balancers interspersed. And when a problem hits, oftentimes nobody knows where in this group of 400 boxes the problem is. And so my purpose in life is figuring out which box is causing the problem. It can be an application problem, it can be an infrastructure problem, and the symptom is the same. The application slows down or it fails. So I need packet level visibility everywhere in this diagram in order to be able to troubleshoot problems. And that's more than you can do with proxies. That's one of the points I want to make. So I got called a month or two ago on this particular application to troubleshoot a severity 1 problem. It was login failures, login slowdowns and login failures. Pretty much everybody was locked out. It was affecting multiple applications. And I got on the bridge call with 60 people on the call, and nobody had any idea what the root cause was. We had called in the vendor support. They didn't have any idea what the root cause was. The application guys knew that requests were backing up in the app servers. The database guys knew that they were running out of threads, but there were no log messages, which is another point I want to make. There were no log messages anywhere that gave people the root cause of the problem. This had happened multiple times and everybody was stuck. So the sniffer guys are called to swoop in and save the day. And by the way, I'm not the only person that does this. I know counterparts in other large enterprises, other verticals, and they're all doing the same thing. They're all getting called on severity 1 problems. They're all decrypting packets to figure out what's going on. So I started looking at packets on the internet, and because we use a content delivery network, the source IP of the user I'm looking for is obfuscated, so I have no way to find that user except to trace everything in and out of this application, 3 to 4 million packets, decrypt all of it, and look for some identifier like the guy's user ID or origin IP address. So I was able to find a particular user's transaction, his login that was failing. And there was one particular URL, one particular GET that was getting 10-second response time. So I knew it wasn't an internet problem, it was something deeper into our data center. So I moved my tracing down to the tier 2 load balancer, found the same symptom, same URL, 10-second response time. I moved down to the reverse proxy, Above and below, same symptom. I moved down to the web server, found the same symptom. Above the web server, same symptom. So I've looked at 5 tiers of the application already. And this is already more than you can do with proxies. So for the proxy question, 5 layers of proxy is huge. It's expensive. It's millions of dollars. The bigger thing is that it adds production risk. These proxies are devices that can fail, and when they fail now, they're causing a production outage themselves. They complicate troubleshooting, and no enterprise wants to put in 100 proxies for me to get the visibility I need. It's a solution that doesn't scale, and it doesn't work for enterprises. Another major solution that's been suggested is endpoint monitoring. I've already mentioned that logs often don't have a clue as to what the problem is. And running full-scale packet captures on endpoints doesn't work. Because of NAT and because of encryption, we often have no way to tell which connection is the right one until we decrypt the data and look for session IDs or other identifiers. So we would be forced to run full-scale packet captures of everything on app servers, on firewalls, on load balancers, and those boxes are not made for it. And I have many anecdotal stories, not from me, of people killing boxes trying to run traces on them. So that's also not a scalable solution. And one other note before I move on the endpoint monitoring is I often need decrypted packet capture where there is no endpoint. Firewalls don't always terminate TLS, load balancers don't always terminate, but yet I often need to put a sniffer above and below a firewall or above and below a load balancer, decrypt the traffic to find a transaction, and then identify if that firewall is causing my slowdown. And if my only trace option is the endpoint, there's no TLS termination, I have no way to get a decrypted trace out of that firewall or load balancer, so I'm blind. And I've solved critical problems with that process of tracing above and below devices. So endpoint tracing doesn't work, it's not scalable, it doesn't solve the problems. So anyways, I moved my trace point below the web server, and now the web server made a different call. So again, completely different TLS connection, completely different URL. I have no way to find this in a trace that's encrypted except to decrypt it and look for identifiers like session IDs. So there's a new URL, and then down in the application payload of the packet, there are individual application layer function calls. Get LDAP ID, and that got a fast response. There's 2 or 3 others that also got a fast response. And then the 4th call at the application layer, 10-second response time. So now I know exactly where this problem is, this particular call to get a token, getting 10-second response time. So the problem happened again. We're all in the bridge call. And I said, look, when this problem happens, there's this one call, and that's where the problem is. And the database guy said, oh, that call accesses a unique database table and a unique stored procedure. And it wasn't 15 seconds later that the other database guy said, I see the problem. This particular stored procedure had an expensive operation, it was single-threaded, and users were backing up. And that was backing up the database, which is backing up the app servers, which is backing up LDAP, which is backing up other applications. And there was this cascading mess happening from this one function call. And it was the decrypted payload of the packet that was the solution. And there was a question on the list also that said, show me an example where you have to have decrypted packets and there's no other way. And this is that example. There was no other way except to look at the payload of the packet to figure out what was going on. Now there is another alternative, which I've seen from other environments where we don't have packet visibility. And I'll pick on VDI for the moment because VDI obfuscates the payload of the packet into mouse clicks and keystrokes. And when you try to look at it, and it's encrypted in ways you can't decrypt. And in a sniffer trace, you can't see anything and you can't find a transaction. So when you have a long VDI string, like from the other side of the world to our data center, 50 pieces of infrastructure, firewalls, load balancers, and multiple data centers and circuits, and then you get to our data center, more firewalls. Any one of those pieces of infrastructure could be causing your slowdown. And the troubleshooters have no way, if there's no log messages, we have no way to figure out which piece of infrastructure is causing this problem. And I've worked on problems like this. And when the sniffer guys can't get in there and say it's this firewall, then everybody is reduced to guesswork. Let's try upgrading the software. Let's try downgrading the software. Let's try a different network path. And what I've seen from experience is severity ones drag out more than a week, which is an eternity for severity 1 problem. Severity 2 problems drag out for months. And we only survive VDI because it's not everywhere. And this kind of thing only happens once in a while. But TLS is different. TLS is everywhere. All of our critical applications, internal infrastructure, it's all TLS encrypted. We're troubleshooting these environments every day. We have a team of 6 people looking at packets, looking at payloads like I do, and every single day, or just about every single day, we're looking at payloads of packets to figure out problems. And what's going to happen if TLS 1.3 rolls out just as it is without static Diffie-Hellman is that we're going to have severity 1 problems that drag out for more than a week. And we're going to have and it's going to be far more frequent than what we're seeing today. We're going to have severity 2 problems drag out for months. And even this particular problem I described, I was able to get to the root cause in 3 or 4 days. But with TLS 1.3, if I lose my decryption capability, it's going to be 3 or 4 months. And it's going to be a level of pain that enterprises aren't going to be willing or able to handle. It's basically, if I have a problem and TLS doesn't allow me to solve it in a timely manner, it's basically a DDoS attack. It's a TLS 1.3 induced denial of service. So we need a solution for TLS 1.3 in the data center. And if we don't get a solution, the outcome is going to be length of troubleshooting time that we can't deal with. All the focus on creating a secure channel and keeping the bad guys out of it is also locking out the troubleshooters and the threat detection teams from doing the work that they need to do. So we need a solution that solves this problem. And static Diffie-Hellman is an option that allows us to do the troubleshooting that we need in a timely manner so that we can keep our enterprise up.
Thanks. Is this the right slide for you?
So I want to talk briefly about this draft. My name is Matthew Green. I'm one of the authors of this draft. Hold the mic. Okay. There we go. Okay. So I was approached with this problem. And the problem was basically, how do we get enterprises who control an endpoint to be able to access traffic on this endpoint? And the interesting thing about this problem is this is not technically a problem. If you control an endpoint in the TLS system, you control access to secrets. The engineering problem now is how do you get access to those secrets and how do you perform decryption? And how do you do it in a way that doesn't actually harm the TLS protocol or prevent adoption? And so the idea was to try to find a solution that did not require significant changes, did not require the inclusion of kind of unpleasant things into the protocol, and would actually allow enterprises to do real-time decryption of traffic inside of their own data centers. Okay, so there are a handful of possible solutions to this problem, many of which already exist. The first solution is basically to have endpoints, meaning servers, deliver session keys or deliver master secrets that they've derived through some kind of out-of-band channel. This is actually pretty workable. In fact, browsers can already do this. Servers can certainly do it without too many changes. The problem is the number of keys here can be very large. So in order to do this, and remember the requirement is real-time decryption by some kind of middle box, you have to handle 2 problems. First, you have to deliver keys in a very timely manner because these devices that are actually doing monitoring can't cache very much traffic. So if you get desynchronized, if you can't get keys to the right place in the right time, you can lose large amounts of traffic. So this may not work at scale. The second solution is to do something that actually encodes secrets or session keys in band in the TLS protocol. There are a handful of different versions of that. One which I actually like a lot and might be a workable solution is to use a full extension where the client says, I want to participate in this protocol, and the server agrees, and then you do an in-band inclusion, and that may be fine. Unfortunately, some clients, which are already present in the data center, are legacy systems, and they don't include the logic to do that. So it may not work in every case, but I do like it as an alternative approach. What I don't like about this solution is that there are a lot of different variants of this idea, some of which are very hard to detect. I included kind of a joking suggestion, which was by Hovav Shacham, of let's use dual EC DRBG, which is, hilarious, right? I mean, this is a perfect way to do this. We hack our random number generator so that our secrets are generated using something that's predictable. We include something into the protocol where everybody can monitor this, and we can laugh about this, but the truth is, this is a perfectly workable solution, or some variant of this is a workable solution. It's very easy for somebody to do without actually harming the TLS protocol. And if this group says that that's the way things should go, I really suspect that somebody is going to implement something like this. I don't like that because it's completely undetectable if you do it this way, and it's kind of ugly and unpleasant. A third approach, which actually is detectable, is let's not change the TLS protocol. Let's do something other people can recognize. Let's, and this is actually following up on a suggestion by Hugo Kroschek, let's just have, in the particular case where you control an endpoint and you need to monitor connections to that endpoint, let's just have it use a static Diffie-Hellman key. And by static here, I mean it doesn't have to be static for all time. We want the keys to change. It's just that they'll change according to some, maybe, not per connection logic. Maybe there'll be new keys pushed periodically, once a day, once an hour, or something like that. The nice thing about this is it's very hard to deploy this at scale as a kind of, nationwide wiretapping system. You can tell when servers exhibit this behavior, and you can take precautions to prevent browsers to connect to them. It does reduce forward secrecy depending on how quickly you rotate keys, and it has some other issues that may come up as well. Can I get slide? So this is what was proposed in the draft green TLS static draft. It's version 1 now. And basically, it does not suggest a change to the TLS protocol. It says do two things. The first is, here is a way to use the TLS protocol that is consistent with the current TLS 1.3 draft without changes to the protocol using a static key. So this is really just a configuration. The second thing it says is, here are a bunch of security considerations if you do this. Let's be careful about these. And the third thing it does, it says, okay, let's say you want to do this. Here is how you should manage those static keys using a key server. Here's the protocol you should use to actually push them. You don't have to do that, but that's the majority of what's actually in this draft. It also emphasizes that the point of this draft is for servers you control and servers that are inside of the data center, and talks about how you can detect when servers are using this over the internet. And this is a beautiful ASCII art diagram of what that would look like if you like that. Everything inside of the stars is the data center. You have a load balancer that's terminating a connection from the internet. That's a normal ephemeral ECDHE connection. And then you have a bunch of craziness going on in the back end. And there we have static Diffie-Hellman on internal servers. And those are the only connections that can be monitored. Of course, the load balancer can monitor the ephemeral connections too, but that's, that's something that can always happen. Okay, I just want to talk briefly about the security of this approach. I don't think it's very controversial that static Diffie-Hellman, if you leave aside the forward security, forward secrecy considerations, is cryptographically secure. We know that this is something that can be done. FIPS 856A talks about using ephemeral static as a key exchange. TLS 1.2 already has a static mode. We know the implication of this is it reduces forward secrecy, but even if a client repeats a key, as long as client randoms and server randoms change, we should get unique session keys and so on. So the security of this is pretty well understood. There are some risks for server implementations when you use a static key. One of those is, for example, small subgroup attacks or elliptic curve validation problems. One of the things that we did as part of this is we submitted a pull request to the TLS 1.3 standard, which was accepted, actually specifying elliptic curve validation. And so regardless of how this goes, at least there's one kind of good concrete output from this project. Okay, so we know that this is something you could do. I think, one more slide, let's see. Last couple of things, yes. So the majority of these problems, and some people have raised this on the list, is yes, implementations can trip and fall, and they can fail to implement these checks even though they're required. And you know what happens if that happens? Well, people who implement this inside of their data center deliberately and fail to test for these implementation flaws will have a big problem. But if you don't implement static Diffie-Hellman, That's really not going to affect you or the rest of the internet. And the finite field Diffie-Hellman groups also help address these things. So it's really not going to hurt the majority of people. I think that's about it. Is there another slide on here? Oh, yes, sorry. My last point here is that I've kind of approached this as a question, I said this before, kind of harm reduction. So we know that there's a solution space, and there's certainly one part of that solution space is enterprises just don't adopt TLS 1.3. Today they're using 1.2 with static RSA. And I think in general that's a bad thing, but they may continue to do that. I don't know, maybe that's the right thing to do, but it doesn't sound great to me. They could make these dramatic kind of surgical changes to endpoints to deliver session keys. Doesn't sound terrifically good to me. There is a whole constellation of what I call really bad ideas, which I won't go into. But I'm sure that, you know, if this leaves the IETF and goes off to ETSI or ANSI or wherever, lots of bad ideas will be considered. I prefer ideas that are detectable to those bad ideas. And then there are extensions, which actually I'm open to. I think extensions might be a good solution. What we get from static Diffie-Hellman is three things. We don't have to change the TLS protocol so nobody else gets broken. We understand the cryptography here. We know what the trade-offs and the drawbacks are, but we know how to control for them. And more importantly, we can detect it. If somebody puts this on the internet, we will be able to have SSL labs give them an F very easily, and we may have browsers that can actually detect and even block connections to those servers if that's something we want to do. So that's pretty much it for me.
Thank you.
Good morning. I'm Tim Polk from NIST. I am not one of the authors of the draft, but I am actually one of the, I guess we'd say, sponsors of a related project at NIST's National Cybersecurity Center of Excellence. I wanted to give one quick plug on what the NCCOE is, since it's only a couple of years old. Unlike NIST, where we do metrics and standards, the NCCOE mission is really all about tech transfer, about adoption, about deployment. It is actually, we don't develop new standards at the NCCOE. We try to take the standards and the technologies that are currently available and demonstrate how we can really provide security while meeting business needs, while meeting operational requirements. So from that respect, we've been hearing that there was an issue with meeting operational requirements with TLS 1.3. We thought that was actually an important problem, but it sounded like an important problem. Back in May, we convened a group of industry folks to talk about a couple of, not just this problem, but a couple of other certificate management and other related problems that have to do with really wide-scale use of TLS. And this included people from financial sector, manufacturing, healthcare, government, also included a couple of our partner technology companies. We had this roundtable, and in the discussions, it became clear that even the people who had come to this session to talk about other problems, when they heard about this, they said, oh yeah, we have that problem too. That really does need to get fixed. So the operational requirements in our assessment are something that are pretty widely held across more than just the financial sectors. We looked at the current practices and, staying on 1.2 with static RSA, again, doesn't seem to me to be the best solution. It is one that meets the operational requirements. But when we looked at this, we came to the conclusion that we could do better with TLS 1.3, that if we introduced a central key manager, did some automation, used draft green, the NIST key management guidelines to make sure that we are being as secure as we can there, some other existing standards, we think that we could do better. So, this is our objective: collaborate with industry, foster support, resolve some impediments to the deployment of TLS 1.3, and get better security than we have today. So we've come up with this as a notional architecture. It doesn't look any different from what you saw in draft green. Go to the next one. And what we're proposing is to run an experiment where we're basically trying to demonstrate 4 different scenarios using security appliances to gain visibility to the traffic at different places within the data center. troubleshooting tools getting visibility, and then also adding the problem of TLS 1.3 resumption. So there's just, we've come up with a set that we say, if we think we cover these, we probably have demonstrated all of the things that we think we'll need to do for industry to actually solve their operational requirements. So what's next? The NCCOE has a rather rigorous process, and I'd love to tell you all about it, but I didn't have time in this particular, I don't want to divert the attention, but we're going to be posting what's called a proposed project description. It'll go into the Federal Register, it'll also go on our website, and it will say, this is what we think we ought to be doing, and we're looking for partners who want to work with us. That will happen in the middle of August. Over the next month or so after that, maybe 2 months, we will collect all of our partners, and we will do some negotiation and discussion about, is that really the solution we want to work on? Or there may be tweaks to the architecture or the protocols that we choose. We could augment the scenarios if we need to address other problems. Then the deliverables that we would be doing is we would produce a proof of concept implementation, and then a number of documents. So we'll put together a proof of concept that has all of those pieces, uses the protocols, and what we would be trying to really demonstrate is that we can really improve the, we can really tighten up the lifespan of those keys that we are sharing within the enterprise. We would publish a NIST 1800 series practice guide. You may be familiar with some of our 800 series documents, which are the security documents that NIST puts out. The 1800 series is actually these practice guides that tell people how, if you want to do what we did in the proof of concept, here's all the steps that we went through. Some of these are like 400 or 500 pages long. I mean, they're really completely, you know, every breath we take is pretty much documented in there. But there's 3 parts. So there's an executive summary. There's how you explain this to your decision makers, and then there is the every step you take. The third thing that we would do, which is not actually something that we do in all NCCOA projects, but something we would do in this one, is that we would submit an IETF draft that says, this is what we did, it worked, it didn't work, this is how, these were the problems we found, this is how the kind of velocities that we thought we could, kind of key lifetimes that we thought we could manage, and that would be documented, since we think that would be useful to people who are using the TLS protocol. At this point, I'm going to turn it over to Russ.
Hi, I'm Russ Housley. I only have one slide, this last one, then Steve Farrell's coming up with me.
I know it's good.
That's why we thought we'd end with it. Basically, the idea is that within the enterprise, the server, in conjunction with the key manager, is established. The server is working with the key manager to get the keying material to all of the places where the decryption needs to happen, where that visibility is required. And RC 2804 describes exactly what wiretapping is, and then goes on to say that the IETF will not work on that. But basically what it says is it's wiretapping when neither the client nor the server know that it's going on. And in this case, the server is heavily involved, working with the key manager, accepting that key, and then actually proactively using it. So the server is enabling it. So for that reason, we think it's not in violation of 2804 in any way. We recognize that some people think that this is still something that shouldn't be worked on in this group, but we would hope that we would get as much TLS knowledge reviewing this document so we can produce as secure a solution as possible. Stephen, I think you're up.
Thanks, Russ.
Hey, Stephen Farrell.
You're pulling up that thing?
Yeah. Take the mic.
So this whole thing is a terrible idea, we just shouldn't do it. How many people had a look at this text before now? Okay, quite a lot, so I'll just skip through it pretty quickly. I'd actually like to extend the discussion a bit, I mean, we keep seeing these proposals for breaking TLS, and this is yet another one. So the question I have with the working group is, aside from sending this to Dev Null, should we, or is it worthwhile trying to document some of the reasons why these things are a bad idea, or a bad idea in the IETF, and would that help us to kind of avoid them in future a bit better? So again, I have this repository. There's a bunch of arguments against this kind of madness, and bear in mind, you don't need to accept every single argument. Any one killer argument should be good. So firstly, generally people do this and they come along and they say, here's my thing I care about. It's a data center, it's an enterprise, and I don't care about all the rest. And turns out TLS is so widely used, that's just a dumb idea. Secondly, we also should, and I think the IETF has consensus on this, consider the kind of pervasive monitoring aspects of this. So it just doesn't kind of wash to say, everything will be okay, it's only in my data center, nobody else is going to go bad at this. Thirdly, TLS is hard, right? So we've seen over the years many implementation errors, some protocol errors. Adding complexity like this, adding weaknesses like this deliberately is going to make it worse, right? Implementations like this will keep making things worse. We already heard just the argument that, we should do it here because if we don't do it here, it'll be done worse elsewhere. I think go find it elsewhere. We have a liaison process. I think there's one liaison statement has gone to Etsy recently, is that right? Kathleen? Did the Etsy liaison? Okay, so the IAB recently sent a liaison to Etsy saying, the SecADs, whatever, yeah. Sorry, sent a liaison to Etsy saying, your MCTLS thing is whatever, bad. Also, the IAB, to the extent that we trust and love them, gave us a statement to say that we should be encrypting more. That's a good thing. Not doing the opposite is kind of a good plan. And lastly, I think an interesting point that could be maybe fleshed out more is that a lot of these proposals, maybe a little less so with Graph Green, but definitely more so with some of the other older ones, they're really trying to turn TLS from a two-party protocol, ignoring CAs, into a multi-party protocol and not change the interface to the applications, which kind of just doesn't work, right? And the problem that people have and why they seem to keep coming back is that they know that if they propose a new multi-party protocol, it has zero chance of being deployed. So I think maybe fleshing that out and explaining that to people and understanding it better ourselves might be part of this possible work item of saying don't break TLS. So scroll down. So we have here a bunch of specific arguments. I'll kind of flick through them relatively quickly because I think most of them are on the list. A lot of this is just kind of scraped from mailing list traffic, the points other people made basically. So first of all, breaking TLS is not part of the working group charter. The working group is chartered to make TLS better, not to make it worse. Another charter issue was raised that even if you did accept that this Graph Green proposal was something that was crazy but we should do for some reason, then it still is outside the charter of TLS because their claim by the authors is it doesn't change TLS, therefore there's nothing to do, except it does add this wiretapping API, and that's not part of TLS. So they should, if they want, come back and argue to do this outside TLS. A process kind of thing is that we've seen that TLS 1.3 is almost done, and DTLS 1.3 is on the way. If you look at the abstract of TLS 1.3, it says this is designed to prevent eavesdropping. If this working group, or even if the IETF took on this kind of work, that would no longer be true. Are we going to issue one of our most important security RFCs with a blatantly false statement in the abstract? Is that credible? I don't think so. On the same lines, Christian, I think, proposed a PR for TLS 1.3 that's designed to basically make it harder for people to pull this bad trick. Again, if somebody in the IETF takes on that work, we're just getting schizophrenic. We're fighting against ourselves. We've had, I think, quite a success in TLS 1.3 in attracting and getting interaction with academic cryptographers who have done significant work on doing analyses of the protocol. I think that was a great success. I think it would be great to kind of replicate it. I think that we put that at risk in the sense that if we start changing the protocol like this, and regardless of what people say, adding a wiretap API changes the protocol. It changes the environment in which it's used. that might invalidate a whole bunch of analyses. Certainly those analyses that have been done did not take this into account. We also put at risk the process of inviting those people to help us. Because I suspect some of those might be a little bit pissed off if at the last minute we kind of change the entire kind of situation and say, oh, by the way, we're wiretapping. There are some specific issues with static TLS that, or static DH that Kenny has pointed out that it can lead to implementation failures and particularly spectacular ones. If you look, there's a link there to an attack from, I forget his name. Is Kenny here? Say again? Somovsky. Zoborovsky, sorry. Okay, so there are particular attacks that can be really kind of catastrophic. I think in that case, the actual private key leaks out. So the DH secret leaks out. Or the DH secret leaks out? Yes. Quick is another kind of process issue. So I think the quick protocol is very like TLS. If, for some crazy reason, we made the wrong decision and said, let's do something about this, that something will impact on quick. Because exactly the same stuff will happen. Probably IPsec, probably everything. If we accept this idea of wiretap APIs, why wouldn't we just do it for one thing? Where am I now? Okay, yes, point 8. This within the enterprise stuff is just bullshit, right? This has nothing to do with the protocol. There's no kind of magic boundary there. The authors themselves agree. There's nothing you can do to say that there's any way of enforcing it. If you do it and specify this, it's going to apply not just within enterprises. All arguments that say this is only being done within the enterprise are just nonsense. So, and again, we have cases, so I think the Laravel case is kind of interesting if you argue that this is not a wiretapping thing, because it was exactly what they wanted was to extract the private key material. So we have cases where exactly this approach was sought by authorities in order to do essentially wiretapping. I'll come back to the wiretapping so you can scroll down a bit. So the answer is it is a wiretapping thing. It does meet 2804. So you get down to 11. It's pervasive monitoring. If you look again at some of the concerns people had about integer Diffie-Hellman and maybe too short primes, there is an API that some of the decryptor API that they were using basically would need to call out to exactly this kind of API. So the point is, if you have a please give me your private Diffie-Hellman value API, that would fit in exactly to what's been reported, and you can follow the links, to have been done in cases of pervasive monitoring. So it's a perfect tool for pervasive monitoring. Again, we have kind of consensus that's an attack. Also, we have BCP 200, which is rather old RFC, but a rather new BCP, again, on which the IETF has consensus. And it says, don't do crap crypto. And essentially, we know that static Diffie-Hellman here is worse than what we are otherwise doing. That means it's crap crypto. There's a whole bunch of text in that BCP that kind of does apply here, even though the context was slightly different when that was written. It was more about mandated key escrow. But essentially, this is kind of doing the same thing at the corporate level as opposed to necessarily at the government level. Again, Nick Sullivan pointed out some issues with the static Diffie-Hellman proposal. Those are real. Open scrutiny as an argument. Well, yeah, I think you can make an argument, and again, this would need to be fleshed out more, that while the kind of scrutiny we provide in the IETF is good for good crypto, it's not necessarily good for bad crypto. I think Matt was a co-author on a fine paper called Keys Under Doormats, and if you look at some text quoted from that, it seems pretty clear that what we're talking about here is exceptional access, which is exactly what that paper argues against. It puzzles me. And once somebody on the list, I think, I'm not sure it was facetious or not, suggested that if you have this kind of wiretapping API and it was visible or invisible, you could actually say, this is part of my terms and conditions. Okay. The question of visibility is interesting though. And again, I think this could be a little bit of further analysis. The claim is that this scheme would be visible to people on the internet and SSL labs would give you an F. If that's the case, it wouldn't be turned on. What they would do is they would change the scheme to be something that's not detectable. Right? As soon as you have the API, as soon as you're able to do that, give it the Diffie-Hellman private, there's many ways you can come up with in which you could vary that value over time, or go back to just giving a seed for some random number generation or whatever, so that it would become undetectable. I bet it's 100% sure that would happen. So the argument about this being detectable I think is mistaken at best. Go ahead. Okay. So again, an argument was made that if we don't develop this solution in the IETF, worse solutions will be developed. And I think again that's wrong, because with the exact same level of evidence offered for this argument, I can have a counter argument that says no, it's the opposite. So basically, the worst solutions, I think, once you have the API, if we did work on this API, lots and lots and lots of worse solutions, and many definitions of worse, pick your own definition, you can find one, then that'll happen. Because the API exists, it'll be used, it'll be extended, and it's impossible to do this without it being extensible. The draft itself, I think, doesn't seem to mention active attacks. So if you give out this value, the person who's got the decrypted can also do active attacks. So that, again, would need a bunch of analysis. Now we may have a whole bunch of different things happening. I think, again, the point was made on the list that if we standardize this, no matter how much people say we only want it to be used in the data center, that's not what's going to happen. The code would leak out, it would start to be used on the internet, and that's what's going to happen. So again, it's not an enterprise thing. Even if you have an enterprise motivation, the proposed solution, or any proposed solution in this space, is not an enterprise solution. Scroll down to wiretapping. Okay. So Russ, I think, is claiming that this is not needed. I think if you look at this figure, it's even obvious. Scroll down a bit more and we'll make it even more obvious. So we want to be lawyerly about the definition, and we look at the picture there. We have an email scenario where I have a mail sender, sends to their submit server over SMTP over TLS. Submit server forwards it on to the MX of the recipient. Happens to be, as in our particular college network, that we have a third party who does antivirus scanning for us. So it's again over SMTP over TLS. They will then forward it on, if it's all good, to the final mail recipient, the recipient MPA, who then goes. So we have a whole bunch of TLS sessions. If that middle one, the AD scanner, is wiretapped, let's say because of a national security letter or some local jurisdictional thing, the mail from the sender to the receiver is being given over to the local law enforcement, presumably, without the knowledge of the sender, the receiver, the sender's organization, or the receiver's organization. So the idea that this is not wiretapping is just nonsense. Scroll down for one more example. If you consider hosted websites, so particularly the kind of hosting that, let's say, WordPress.com does, where you can maybe get a vanity domain, but you don't have shell access to the machine. So you're using this website, you have some level of application layer control, but nothing at the control at the level of the TLS session. That's all controlled by, let's say, the equivalent of WordPress.com. If they turn this on, if you have two people commenting into one another on a blog, they're being wiretapped. Doesn't matter that the TLS server knows about it, because the TLS server is not the sender, it's not the receiver, it's a third party. Okay, let's scroll down a little bit more for the end. So lastly, again, I would like to see us kill this proposal dead. After having done that, I would like us to think about, and I really don't know what the right answer is here. Would it be useful for us to document some of this kind of stuff in an ROC? Would that save us time the next time this kind of bad idea fairly pops up? Or what? So I think it'd be interesting. There's a whole, as you can see, history of these kind of proposals. They vary different ways, but they come up at a certain frequency. Like it's more than one every 2 years. So the question is to the group, and I don't know the right answer. Do we think it would save us time if we document some of this, so that the next time it comes up, we can at least point them there? But as you can see already, with 2804, with BCP 200, 7258, we already have a lot of things at which to point, but yet they keep coming back anyway. So I think that's my question to the group after having killed this patent idea.
All right. Thank you.
So again, we've had hundreds of emails about this particular topic. If you would like to get up and query points about that have been raised, please do so now. We're going to try to do kind of strict flow control. Remember, keep it professional at the mic as well.
Philhan Baker. Actually, I agree with both sides. And now my problem here is coming from the PKI world. I saw what happened with Blue Coat & Co., who basically, we didn't make holes in the web PKI for them, so they blasted them through with dynamite. The other point that I'd make is, Stephen made a great argument about slippery slopes and so on. There is a slippery slope here, but cast your mind back to the origins of SSL and server-gated crypto. We've actually gone in the reverse direction. When SSL was born, you only had 40 bits. And you had to turn on the 128-bit, and there was actually an escrow mechanism. On the technical side, I don't like the way you're doing it. I think the key manager is bogus. The way that I would do it, I'd use a different Diffie-Hellman key every time.
So that's part of the technical bits. I mean,
yeah. I would like to have this written in such a way that if it gets released into the wild, it's less likely to be compatible with the legacy infrastructure. And at the moment, it's too compatible. But the other thing I'd like people to think about, when I started in computing, I was an intern at ICI, and I was doing SCADA data control, real-time process control before we had the name SCADA. And on a chemical plant, you do not encrypt your data because you want to have this type of monitoring. And I'd like to encrypt. So you have a security choice here, and you need to be rather careful because any security problem I know is really, really easy to solve if you decide to solve that one to the exclusion of all others. And to achieve real security, you have to have a balance. And I would rather internal data centers and chemical plants are encrypted than design the crypto in such a way that they can't apply it.
Paul Wouters, Red Hat. I want to quote 2 lines from RFC 4307 BIS, currently, actually yesterday approved by IESG, currently in the RFC editor queue, talking about Diffie-Hellman group 22, 23, and 24, which are basically suspicious, ephemeral, leash-like Diffie-Hellman groups. This has resulted in group 22 to be demoted to must not. Group 23 and 24 have been demoted to should not and are expected to be further downgraded in the near future to must not. So anyone who is worried about TLS, I welcome you to use IPsec in the near future.
Dan Harkins. Several years ago, I worked for a large router company that was interested in key escrow, and they developed some intellectual property on that topic. So I wanted to make the authors of this draft aware that of that fact, and that an IPR disclosure was made on your draft this morning.
Hi, this is Daniel Kahn-Gilmore from the ACLU. I want to express my disappointment with this draft. I don't think this is a good idea. I don't think we should be doing it. Specifically, I mean, Stephen's already made a series of the points, but export cipher suites were brought up at the mic here, and I want to remind everyone that as recently as last year, we have had problems related to the fact that export cipher suites were standardized something on the order of 20 years ago. And there is nothing in this mechanism that will actually limit it to the data center use for which it is proposed. And I want to suggest that if we standardize a mechanism like this, the first time that we see a problem with this leaking outside of the data center might be that we notice it, might be soon. But the last time that we see a problem like this is going to be way, way, way in the future. Standardizing something like this is a really bad idea if we want to keep the internet secure.
Hi. Is that for me? Cool. Thanks. I'll sit down now. Yeah, Rich Salzaka, I have a problem. I'm torn between, yeah, I find this professionally and personally not a good thing. But I also remember Dave Clark's talk at the last plenary, which was, we should try to tilt the playing field if people are going to do things. And so I want to be aware of that. The only answer I come up with so far is sort of the traditional US Congress thing, is we just kick it down the road. We haven't even finished TLS 1.3. It's clear that anything that addresses these issues is not going to be part of the core. So I'd really like to see us wait 2 years. until we get TLS 1.3 deployed, see what the real problems are. Nobody is being required to deploy TLS 1.3 now. PCI hasn't even required TLS 1.2 yet. So I think it's premature. If we adopt the draft, let's abandon it immediately and come back and look at it in a year or two. Thanks.
Hi, I'm Darren Pettis from a large financial organization. It's pretty tough to follow up, Rich, with all the applause. But I'm just here today, thank you, because we had been here in the past in Seoul, Korea, part of the organization with the gentleman that proposed the draft. Just to understand the technical issues, we do it today with RSA, and we aren't asking to bring it back. We understand that we moved forward and it's gone, and so we're looking for a new mechanism. We took a lot of the technical solutions that were offered up to us and met with a lot of individuals, other enterprises to understand what could be done. We brought on a lot of people that understand the technology much better than I do, the encryption, people that understand the IETF, and we're trying to work with you because we'd like to take a standards-based approach and figure out the best way. This was one of the ones that was come up with. It seemed like the best one to us, but it may not to you as the experts. Very open to other ideas, and we definitely don't want to preclude the actual 1.3 draft going forward. That has to happen. I'm a privacy advocate myself, and I'm very appreciative of that. So just looking for this group's help to figure out what the best way forward is, and I'd like to ask for your help. Thank you.
So the line is quite long at this point. We only have 30 minutes left, so I want to make sure that everybody keeps it short to the point. Sorry, Roman, for jumping in the middle. And I think we're actually going to clip the line at the end. There.
Okay, Roman Dinelli from CMU. What I didn't see on the mailing list or in the presentation here was talking about the security use case for this, specifically in incident response. And I just wanted to highlight about techniques used when you're hunting active compromise, specifically finding lateral movement. And the ability to do ad hoc instrumentation is really key to finding those IOCs that you can then put in all those proxies and firewalls. And the ability to do that passive capture and the decrypt really helps the analyst do that kind of response.
Fleming Andreasen, Cisco Security Business Group. Speaking specific to the policy issue here, I think the operational issues are very real. I think there are other use case scenarios as well that could, greatly benefit from this. And I think pushing everything to the end point, in practice, it does not work. So I'm very much in support of trying to take on this issue. I don't think the community is served by viewing this as a black or white discussion, right? Either we get privacy or, we get this thing and the two are completely at odds with each other. I think having a pragmatic approach to it would be useful. To some extent, this reminds me of some of the NAT discussions we had many years ago. NATs are bad, right? They're going to prevent us from essentially getting IPv6 deployed, so we should ignore them forever. I think we all understand how that worked out, right? In the end, I think the community is better served by acknowledging this problem and finding a way of actually addressing it. Specific technical solutions might be premature to pick between those, but I definitely support taking on this issue.
Nalini Elkins. Yes, I think there are some very real problems from very real people doing real things. And, the internet is not just a service. It's used by real people, grandma, to do real things like internet banking. And if you're hearing from people that internet banking, stock trading, insurance, all these things are going to have lots and lots of problems, I think it behooves us to listen.
Mark Nottingham, gloriously unaffiliated. As Stephen mentioned, this is not the first time we've seen this sort of thing. A couple of years ago, we had proposals quite strongly made with similar kinds of justifications in the HTTP working group. We looked at that and we had some discussions around the why timeframe, and we chose not to accept that work. And the reasoning was that HTTPS is defined explicitly as an end-to-end encrypted protocol. and therefore a two-party protocol. And we did not have a way to get the informed consent, if I want to use that term, of the whole population of the planet to change the semantics of protocol they were already using. I kind of think that's the case here too. You're changing the nature of the protocol pretty fundamentally. And although Stephen had a lot of information up there, I kind of do see that argument. Yeah.
Ted Hardy, gloriously affiliated with a couple of different things. And in this case, though, just speaking for myself, I think there are 2 points here. One that relates in some ways to the point Mark just made, and that is that forward secrecy is a feature of this protocol. This proposal turns off forward secrecy in certain contexts without it being obvious to the end users that forward secrecy has been removed. In particular, you can't tell on the first connection where a particular key is used. You may be able to detect it over multiple connections, but it's a very basic part of protocol design that when you have a feature which will or will not be present, that you also have a way to indicate whether it is not or present, and for all the parties of a communication to signal whether or not they are okay with it being present or not. I do not believe that this proposal meets that basic requirement of protocol design. As a result, if it came back, I would suggest that it be changed fairly fundamentally so that it did have that. Secondly, if it comes back with that added, I believe there's a very fundamental question that the working group has to answer of what's the domain of analysis. And I believe Russ read us section 3 of a particular RFC 2048, but did not read us section 4, which is an interesting follow-on piece of reading because it says we're not taking a moral standpoint here. We're taking a technical one. And a very basic part of that technical one is that if you define a piece of technology for use in a specific use case or domain, you must expect it to be used in other places as well. And I believe many people have made the same point as RFC 2048, that if you expect this to be defined for use in a particular domain like a data center, you must expect that your analysis cover the other domains in which it will be used. So I believe any subsequent analysis must take into account all of the domains of use, not just the data center.
Max Bala, Cable Labs. I just want to say that I really support what Farrell just said and presented, and all the arguments about not adopting this draft. All the arguments about the direction of the TLS 1.3, I think still stand. My personal experience with large corporate environment is that most of the time you try to say that, this is a problem if your internal architecture is outdated. There's many different ways to solve this problem, and if you're not ready for TLS 1.3, nobody forces you to do it. I would say that if you do deploy TLS 1.3, it should be conformant to what the principles were. So I'm strongly oppose this.
Ralph Drums, Living the Dream. As the folks here in the room and outside the room consider the discussion that we had today, consider the presentations that have been made, and consider what the working group is going to do going forward, I'd like to emphasize keeping separate the fundamental abstract questions and problems that are being discussed, the operational problems, the pragmatic operational problems that the enterprise network people have to solve, and the particular proposal that's on the table in this document. There's been a lot of discussion to the effect of this should be rejected, this should not be accepted, this document should not be taken on as a working group document. And I felt as though there wasn't that separation between the consideration of the fundamental problem, the abstract issues that the operational people need to solve, and the particular solution that was put forward. Exactly as you emphasized, Sean, the authors of this proposal are more than happy to give up change control to the working group. If the working group comes back with some entirely different solution proposal that solves the operational problems, that would be great. So keep those two things separate in your mind as you decide about how to go forward. Thanks.
So we actually are cutting the line behind the guy with the ponytail. I'm sorry, but you're at the end of the line. So anybody comes behind you, just shoot them away.
Roland Evans, Arbor Networks. I wanted to echo and expand upon just very briefly the troubleshooting and reliability and availability aspects of being able to inspect traffic within one's own sphere of administrative control. It's absolutely vital in order to keep services up and running and available. From a security standpoint, it's also vital to have the visibility to be able to understand when bad things being done by bad people are taking place and being able to then do something about it. And unfortunately, the only place that can really be done in many, many cases is on the wire, not at the endpoint. The folks who are bringing this to our attention live and breathe crypto. It's an integral part of their business model. They actually end up facing, potential fines and legal liabilities if they don't safeguard our information. The banks, the healthcare providers, the hospitals, the governmental agencies that all of us depend upon for different services that we all use every day, and millions of other people do around the world as well. So while there may be both pros and cons to this specific proposal, and there are, I would hope that the sense of the working group would recognize that this is a legitimate issue and that we need to find a solution so that we don't end up pushing these industries into crypto that is proprietary in nature, that has been dreamt up by groups like Etsy or the IEEE in a smoke-filled room. We want to keep them on the standards-based crypto path with strong crypto. Thank you.
Hi, Jeff Hodges, PayPal. We want to echo the points that Ralph and Darren Pettis and Roland and Fleming, who was in line before us, that there are, from the enterprise perspective, valid needs to be able to do this sort of thing, and the working group and just the individuals in the room. It would be great if we all kind of work together to try to address this problem. And it's not just a single point in time. One could view these kinds of needs as transitional over many years. People are stuck in where they are today and need a migration path to get to the point where hopefully you can actually have forward secure inside the data center, but it's not going to happen tomorrow. It's going to be down the road, and it would be great to have a migration path that has been scrutinized by appropriate experts and such. So following on from that, there have been folks from certain organizations in the argument who have said, we don't have to do this. We cover the bases some other way. It would be really great, I think, to help this become a migration path for those kinds of folks to share their secret sauce and help the industry as a whole move towards greater overall security.
Christian Wiedemann. I would like to comment on, to support points that Steve and Stephen and Ted have been doing, and take the lava bit scenario. When the lava bit scenario is you have a provider of service, and that provider is being compelled to turn on a feature so that basically somebody can monitor their traffic. That's completely outside the data center scenario. The reason why this draft is, when this kind of approach is very dangerous, is that because you assume that you are using the same software on this lava bit server and on the data centers, the people that are doing the coercion can ask to turn on that feature of the software in another place. And that's why I don't like at all the feature of this particular proposal, which is basically keeping the online format unchanged. If any proposal that is designed for the data center, much like Ted was saying, came up with a big red flag in the wire packet that says, I'm turning that proposal on, then that proposal will not be used, that would not be as easy to abuse. Because if someone goes to the liability center and says, hey, download that feature, please, you have it in your software, there's no big deal, we can compel it. You will turn it, and then all your packets that have been compelled to do that will also have the big red flag, and that will be noticeable by everybody. And then you could take counteractions. And I think that this big red flag kind of requirement is something that we should absolutely have, and we don't right now. That's the question I was asking to the author. What kind of design have you done to ensure in your proposal that is only used in the data
Okay,
center?
we need to keep the line moving, sorry.
Okay.
Daniel Franca, Akamai. So I support adoption of this proposal with draft 0 as a starting point, but I oppose draft 1. The reason for that is that draft 0 is informational. Its message is essentially, here's a thing that it is possible to do with TLS. Here are the risks and benefits if you choose to do it. I think that's a good message. That is indeed, as Professor Green characterizes it, harm reduction. It helps people make an educated business decision. Draft 1, on the other hand, is standards track. And I think that crosses a line from harm reduction to encouraging and enabling poor decisions by giving them the mantle of IETF support.
Kenny Patterson from Royal Holloway and also co-chair of the Crypto Forum Research Group. Thanks, Daniel. So it was said earlier that this proposal will be an advancement on what we were doing previously with static RSA in the data center. I'd like to point out in the current draft, it absolutely is not, because there's nothing that requires the key share to be rotated at any point. It says it should be rotated. My suggestion for the working group is to adopt the draft and force the key to be rotated for every connection. Let me go back to something I said in September 16th last year when the financial community came to this group and asked for RSA to be reinstated. No. Rationale, we're trying to build a more secure internet. Thank you.
Hi, Sharon Goldberg from Boston University. A lot of the points that I wanted to make were already made. I'll just make the one main one. I want to support what Stephen Farrell said earlier, and I also want to point out that this proposal is not tied to the data center. I don't see how this proposal forces this mechanism to be used in the data center, and so for that reason, I don't support this at all. Thank you.
Hi, so I'm Deb Cooley from NSA. This is sort of a personal opinion though. So I believe that if you take on this draft here, you control the draft and you control what's written in the draft. You can ask for a mechanism to be in place that shows that that states that this is what's happening, right? So that the other end knows that it's happening. If you let this go underground, which is the way that it happened with static RSA in the past, you don't know what's going to happen. And I do agree with PHP, right? So, you're either going to blow through it with a stick of dynamite as opposed to controlling it. So if you take the draft, you control the draft, and it happens the way you want it to happen.
Hello, my name is Taro Tarakia. I'm with the Open Technology Fund. I want to add my voice to the people disappointed in this draft. One thing I wanted to add is if we're also worried about pushing people in data centers away by adopting this, there's also lots of people who depend on TLS and depend on forward security for the practice of their rights, their human rights, and shouldn't we also be worried about pushing those people away from TLS if we adopt such a draft? Thank you.
All right, Kathleen, time to get up.
Okay, so I think at this point, we've heard a discussion from a number of folks, and there's been a lot of different points raised. I think we would like to, at this point, take a hum on the basic question here, which is this, wait a sec, is this particular subject of passive decryption in the data center something the working group should consider? So we'll ask for a yes and a no. And not what, I want to clarify, it's not for this particular proposal, okay? The technical details of the proposal can be different, but basically this topic of, is this something that the working group should consider?
Stephen Farrell, so just to nitpick the question, as you knew somebody would. I don't believe passive is correct here. If you took draft green, you can do active attacks.
So, say that again?
Draft green is not a mechanism for passive decryption. It allows the attacker to be active.
Okay.
So the word passive here is confusing.
Fair enough. Okay, we can remove the word.
So Ralph was pointing out that, well, sorry.
Right. Once again, I'll emphasize that point I made a little while ago. Separate the particular solution in the draft from the abstraction of the operational requirement. So this is talking about passive decryption. Whether or not static pH is passive or active, I don't care. What we're talking about right now is passive decryption.
So A, you're saying your draft is broken?
No, I'm saying that we're not considering the draft at this point.
Yeah, we're not.
In that case, B, it's not clear to me there is any solution that allows passive decryption without active attacks.
That's the question.
Well, in that case, this is not a good question.
So, sorry to add another nitpick voice to the questions. This is DKG. We have been considering this question for the last several weeks on the mailing list and here. Is that so? What is this question like? I mean, if people keep coming back here and trying to drag this in, I will continue to consider it and push back on it. So I'm not going to say that I'm not going to push back on it if that happens. But I don't know how to hum, basically.
So,
do you see what I'm saying?
So if we say we're not going to continue discussion on this, then we don't. It's a discussion that gets shut down in the working group, right? That we don't consider this.
The draft has finally come to the working group and they've asked for working group adoption. It happened on the mailing list. Now we're doing it again here in the working group. So
Lucy Lynch.
Trying to replace that, so.
Lucy Lynch, a process suggestion. If you would take a hum first on whether or not to accept the draft, and then take a hum on a question that the group might be interested in pursuing.
Yeah, I think that's clear because this is just not clear if it's the draft or the whole idea of breaking TLS.
We're going to continue with the original hum here. Original hum is this a subject that the working group should consider? This is the topic of decryption of data within the data center for various purposes, right? This is the topic. It's what we've been talking about.
So you just omitted the word passive. Is that intentional?
I omitted the word passive.
Thank you.
That was intentional, yes. Okay, so hum now if you think the working group should consider this topic. Hum now if you think the working group should not consider this topic.
So we'll get together with our AD and discuss what just happened. I mean, it seemed to me that it was pretty even. And I think that means we are not shutting the discussion down. So we will go from there. And we actually ended 6 minutes early, so thank you.
Yes.
Sorry, just before you do, I would like to get a sense, maybe on the list and not here, as is the working group interested in documenting how to not break TLS and the reasons to not break TLS?
So we do have to take it to the list, so let's
I'm fine with doing that on the
point.
list, but we will do that, Jess?
Yeah.
Just to be clear, because the microphone kind of warbled a little bit. Does that mean the proposal is being shut down, or the proposal is being continued, or
So the idea is still being discussed, not the particular.
Right. Okay. It just was hard to understand what to say, so it's all
I'll be very clear that like we'll discuss. Okay. I almost kind of like.
You weren't slamming
It's not really the best champagne health fucking foolish shit, man. I kind of forgot about that.
You boys are in for some fun.
It's never gonna happen. Like that was, I mean, dude, in the front of the room.
I know, but we can stack around. What's going to happen?
Somebody else?
Nothing's going to get